Hello, let's do Newton's third law. So what is Newton's third law? Well, it's basically that forces come in pairs. And for example, when you hit a nail with a hammer, the hammer exerts a force on the nail, but the nail also exerts a force on the hammer. When you lean against a wall, so you're pushing against a wall, you're pushing against the wall, applying a force, and the wall's got to apply a force back, otherwise you would go through the wall, wouldn't you? So some people state it as, for every action there is an equal and opposite reaction, and that's the one most people have heard for Newton's third law. And so let's have a look at what they're sometimes referred to as action-reaction pairs. And so here you have your action and here you have your reaction. So we have the exhaust gases are pushed out of the rocket. Now we saw that when we saw the video of the guy on the tricycle with the fire extinguisher. So the exhaust gases are pushed out of the rocket. What's the reaction? The rocket is pushed forward by the gas. A sprinter pushes on starting blocks, the blocks push back. A vase of flowers pushes down on the table pushes back up. A tyre pushes on the road pushes on the tyre. If the road doesn't push on the tyre, you would slip and you wouldn't go anywhere. A softball is hit by a bat, the bat slows down as the ball pushes back. So that's a little bit tricky, that one. So when you hit a softball with a bat, okay, the action is the softball hits the bat slows down. It doesn't have to stop, it just slows down because a force is being applied. And lastly, one that's not really for physical science, an orbiting satellite is attracted to the Earth is attracted to the satellite due to gravity. So forces come in pairs. You have your weight force, so in this case the table must be pushing back with an equal but opposite force. So Newton's first law was all about stationary or constant velocity things. Newton's second law was all about acceleration and deceleration, and Newton's third law is about recognizing forces and reaction forces. So let's just look at a couple of examples. Here we have a balloon that's been released. There's an action of escaping air, and the reaction force on the balloon is making it go, so it goes one way, but there's a reaction force. The air must push back. Here we have a bullet, so the action force is on the bullet, but there's a recoil force. And in our conservation of momentum, we would recognize the relationship to that and the forces. The satellite we mentioned before, pushing up against a tree pushes back. A pushes B pushes A, and you can have magnetic forces. So if you had here, you've got two unlike poles, so they would actually be attracted to each other. So X attracts Y and Y attracts X, and the kettle sitting on the table. So you'll have these questions where you have to think about if you can recognize the actions and reactions. These will be in your OneNote and in your notes that you are given. See if you can have a go at them. And you're also going to have a sheet called Newton's Laws of Motion Questions to do. And the next video we're looking at is going to be on weight. See ya.